Welcome back, chemistry fans. Today, what we're going to do is something then called the net ionic equation or net ionic reaction. What we should see evidence is that when we have two chemicals, double reaction, a double replacement reaction, when they come together, we should be producing either a material that's cloudy, which is an indication that we probably have something that's solid, that's a precipitant settling, or that we have nothing. It will be clear. It may change color, but it's not going to be cloudy. And that is the evidence that what we have is a net ionic equation that's not occurring. There's nothing that's actually reacting. Everything is staying dissociated and it's not coupling back together. So let's see if we can find those evidence. Let me share with you my camera, or let me change my camera screen. What we're going to start with is just merely a nice little glass of water. Nothing special about that one. And what we're going to start with is our first reaction, which is silver nitrate coupled with calcium chloride. So we're going to take these two materials and we're going to add them one at a time into our container here. And we're going to see what happens as a result. So I'm not going to touch these. Just going to add a few little sprinkles of one. And we're just going to dissolve those a little bit. So we're going to stir those up and let them get a little bit dissolved into the water so that they can come into contact with the other material. May have to break it up just a smidge. But what you notice is as it's in this water, it's not changing the color. It's not even turning white or anything like that. It seems like it's completely dissolved. So just be patient with it a little bit there. And it will dissolve. Now I'm going to add my second material, and we're going to see if it turns cloudy, if there's any evidence of one occurring versus the other. So as I add it slowly, what you notice right away is that we start to see evidence here that we have a chemical reaction. It's starting to turn a little bit hazy. So if I were to stir this, what you notice is it completely turns translucent, opaque rather, white. So we have evidence that there is a solid forming. This would be left over in our net ionic equation. It could not be canceled out. All right, so that's our first evidence that something was made, a product gets to stay in the net ionic equation. So I'm going to dump this guy out. I'm going to start over. Let me rinse it out. And I'm going to dry out my container so I don't have any residue left over. Wipe off my container here, wipe off mine. And now we're going to start with our second reaction. So again, I start with just a little bit of water. And we're going to have lead nitrate and potassium iodide. One of these, not going to do anything to the water initially. So we'll just take a little sprinkle, add that into the water. And again, what we're going to watch is to see if it will do anything, any evidence. No, it seems like it's just dissolved nicely there. No big deal. Maybe a faint haze if you were looking at it of color, but not really. The iodine tends to have a little bit of a yellowish color to it. And so then what we're going to do is we're going to add a little bit of lead nitrate to it. And just a sprinkle. I don't have a whole lot in this container, so just a sprinkle. It's all we should see. If I add that to it, oh, instantly you start to see some color popping, maybe a little bit of a haze there starting. So again, we might have ourselves some evidence that we have a chemical reaction. Yeah. Now, what you would notice is it seems to be cloudy. It's not clear. It's not opaque. It's a little bit. And if I were to do this in stronger concentrations, we probably wouldn't be able to see through it. Okay, so we have our second evidence that we have a product that is not going to be able to cancel on a net ionic equation. So now we're going to jump to the third. And we will start with the same process, a little bit of water. This time, what we're going to have in here is copper sulfate and magnesium sulfate. And so my evidence, my background knowledge tells me that copper sulfate doesn't dissolve very fast. So I'm going to start with my magnesium sulfate, put a little bit of that into it, nicely dissolves. And again, nothing bad happening there. It's just clear solution. In fact, probably should have done this from the start. What we're going to do is put a piece of paper underneath so that you can actually see the color change. So there we go. That's a little bit nicer. Now it's a little bit easier to see what we're talking about. And so we're going to add a little bit of this copper sulfate, blue powder to it. Put that in. Now there is a reaction between these two materials. However, as we are stirring this up, there does not appear to be any product that is not staying in solution. It appears that these chemicals are not forming any kind of a haze. They are staying very clear. You can see straight through this. So this is one of the counterclaims to a net ionic equation. There was no precipitant. There was no solid that we would have to cancel out or that we would have to remain. Everything in this reaction would get canceled. So nothing on magnesium and copper sulfate. All right, now we can go to sodium hydroxide. This is a very strong base. Do not want to touch this, and it's going to take it a little while to dissolve. So I put one of those tablets in, and we're going to let that actually set. Now we can actually start to see a little bit of it dissolving. Let me get a different colored piece of paper. And so you can start to see it's dissolving, but it's going to take it a while for it to dissolve out. So we're going to set this one to the side. We will come back to this experiment. And in the meantime, what I'm going to do is I'm going to start with another one. And this one is going to be the calcium carbonate. So I'm going to use calcium carbonate and hydrochloric acid. So we're going to take this little powder, put a dash of that in. And it tends to float for some reason. I'm not quite sure why it wants to float, but we're going to stir it in and make sure you notice, look, it is a nice haze that's going on there. Well, now I'm going to take my HCl and let's see what happens. That is a definite opaque material, but if I start adding my acid to it, what you should start to notice is it starts to clear up. So as I'm adding more and more acid to this, it's going back to the point where there is nothing left in this. So it's very, very fascinating that what we were able to do is reverse that process. And if I continue to work at this, I can get all of that to dissolve out. And so this is another example of a material that is not cloudy. That means everything would dissolve in the reaction. So that one was the calcium carbonate and the HCl. That would be no reaction that's occurring right then. Okay, so now let's go back and let's see how we did with the other one. So we've got our NaOH. It is now dissolved. And again, what I'm going to use is HCl with this. And let's see what happens after we add these two together. So again, let's take one nice squirt to it. There is a reaction, but there's not any haze, any product that occurred. So nothing is occurring on this one. So all we would have is maybe like a pH change. But what you're seeing is evidence that this net ionic equation would not have any products left over. All of the materials would cancel out, and you would just be left with a no reaction. All right, our final reaction that we're going to do is going to be barium hydroxide and potassium chromate. So we'll start with the one that's prettier. So we'll start with the yellow powder. So we'll use it to start. And we'll add, and by the way, that's just bubbles in my water. That's not a haze that's going on there. So I'm just going to add a little sprinkle to my water. And what we should see is that it has a nice yellow tint to it. Very pretty, but it's still translucent, still something that we can look through, see through. Let's now take a little bit of the barium hydroxide. So we'll add those in and we'll see what happens as that starts. Now, you should start to see what a cloud is starting to form over this. And if I stir that up and mix it up, Well, then what we have is a cloudy substance. We have created a product that has a precipitant. And so what that means is there would be something left over in my net ionic equation. All right, well, then we had examples of 3 that did and 3 that didn't. I'm hopeful that you better understand the idea of a net ionic equation as far as it relates to the chemistry of the reactions. Thank you so much for watching. Talk to you again soon. Bye-bye.